Let's go ahead and take a look at Chapter 13. Cloud Forensics. Don't forget, there's no class on Wednesday morning. So there'll be, of course, the usual labs and so forth out there for this chapter. So you can just work on these at that time to work on that.
What's your class Wednesday?
What?
What's your class Wednesday?
My son's having surgery tomorrow.
Oh.
So he'll be coming home Wednesday. So I don't know when I'll be at the hospital. Now, objectives. Describe the main concepts of cloud computing. And I don't know about Wednesday night yet. My wife thinks I'll definitely be available to be online. So, but I'll be broadcasting from home via Zoom. So, I might find different. I might find, definitely he'll shoot home by 7 because he's coming home from the hospital there. But she might have me running around and getting this or that. So I don't know. Describe the main concepts of cloud computing. Summarize legal challenges in conducting cloud forensics. Give an overview of the technical challenges of cloud forensics. Describe how to acquire cloud data. Explain how to conduct a cloud investigation. And explain what remote access tools can be used for cloud investigations. Keeps evolving. Changes. You no longer have the evidence right at somebody's house. You have it at some distance plate. What if it's in another country? The search warrant's not going to do any good in terms of that. Now, cloud computing. Cloud has introduced ways of managing data that didn't exist a decade ago. And I see it evolving even more and more where everything will be on the cloud. Why have your own servers if you can have all of your data maintained by somebody else? Cloud investigations have unique challenges. New standards are being developed to improve security practices and incident responses in cloud environments. Now, the history of the cloud. The idea of cloud computing came from several people. Professor John McCarthy of MIT, Dr. J.C.R. Licklider, JCR. Most databases only have a field one for your middle name, so I wonder how they handle that. Not that it matters. Director at the U.S. Department of Defense Advanced Research Projects Agency, ARPA. In 1999, Salesforce.com developed a web service that applied digital marketing research to business subscribers, and this led the way to the cloud. Amazon created the Amazon Mechanical Turk in 2002, provided storage, computations, human intelligence, started Elastic Compute Cloud, EC2, in 2006, aimed at supporting small businesses. And then after Web 2.0 in 2009, other providers started their own cloud services. Google Apps, Apple iCloud, Microsoft OneDrive, and more. And a lot of these are gearing it just not to storage, but also in some cases providing applications like Google. They're just not having their storage out there, but they came up with your Google Sheets, Google Docs. I forget what document's called, but they got a presentation package too. There is even a free version of Microsoft you can run. So you don't even have to be a student. It's a scaled down version. But again, they're trying to go to the point where they're not just providing storage, but providing the applications. Now, cloud service levels and deployment methods. The National Institute of Standards and Technology, NIST, defines cloud computing as a computing storage system that provides on-demand network access for multiple users and can allocate storage to users to keep up with changes in their needs. There's 3 service levels. Software as a service, SaaS. Applications are delivered via the internet. What?
We covered this
Did we?
last year, last time.
Oh, okay. Yeah, a lot of the stuff blends over. So, platform as a service, PaaS. An OS has been installed on a cloud server. That's what that Mac in the cloud that I talked about. That's kind of that example of that. And infrastructure as a service, IaaS. Customers can rent hardware and install whatever operating systems applications they need. That was a server I had way back when for hosting websites. Paying $500 a month for it. I talked about that in here, didn't I? At least in one of the classes. Again, I could install whatever I wanted on it. They just maintained the hardware. Our locations of evidence. The SaaS, the location of evidence most likely stored on a desktop, laptop, tablet, or smartphone. PaaS, most likely found on a desktop or server, though it could also be stored on a company network or the remote service provider's infrastructure. Sometimes a cloud is not out there on the internet somewhere. Sometimes it's within your company. Depends upon licensing, but you can run expensive software on a server and have people sign on to use it, for example. Some specifically specify you cannot do that. IaaS, usually found on a desktop or server. Infrastructure equipment can be owned by the company or the remote service provider. Now, deployment methods for a cloud. You got public, accessible to anyone. Private, can only be accessed or can be accessed only by people who have the necessary credentials. Community, a way to bring people together for a specific purpose, or hybrid. Enables company to keep some information private, designate other files as public or community information. Some cloud service providers, CSPs and cloud applications, Salesforce, IBM Cloud, Cisco Cloud Computing, Amazon EC2, AT&T Synaptic, Google Cloud Storage, HP Helion, Microsoft Azure. How do you say that? Azure? Heard it. I just can't remember. Zen Server and Zen Center, Windows Management Console, Rackspace, and Oracle Cloud. And again, some of these have applications. Some of them you develop applications for it, like Microsoft's version. That's a development platform you can shoot for. If you've used Visual Studio, then that's one of the options you can develop. Now, basic concepts of cloud forensics. Cloud forensics is a subset of network forensics. Cloud forensics can have 3 dimensions. Organizational, addresses the structure of the cloud. Legal, covers service agreements and other jurisdictional matters. Technical, deals with procedures and specialized applications designed to perform forensics recovery analysis in the cloud. Forensics tool capabilities needed to handle acquiring data. You got your forensics data collection. Must be able to identify, label, record, and acquire data from the cloud. Elastic, static, and live forensics must be able to expand and contract their storage capabilities. Evidence segregation. Different businesses and users share the same applications and storage space. Again, that becomes a challenge because you have to use the user definition and where their data is stored at. Can't go out to an Amazon server and just collect everything. They wouldn't allow it. Investigations in virtualized environments should have the capability to examine virtual systems. Legal challenges in cloud forensics. When investigating a cloud system, consider factors involving a CSP's relationship with cloud users. And then this section explains the CSP's contract obligations with cloud users and how warrants and subpoenas are applied to CSPs and users. Your CSAs, cloud service agreements, contract between a CSP and a customer describes what services are being provided and what level. It includes SLAs, service level agreements. They shall also specify support options, penalties for services not provided, system performance, fees, provided software or hardware. When you contract, whatever it might be, like when we contracted with Blackboard, these are all things you have to consider. What kind of support are they offering? 24/7? What if it goes down in the middle of the night? Are they willing to come in and fix it? You assume a big company would, but if you're going with a smaller company, you'd have to definitely outline that. Penalties for services not provided. If I look at did this for another class. If I got uptime, and let's say our business runs 2 shifts, so we got 80 hours and 200 employees. If we're down for 1 hour a week, for whatever reason, then our uptime is going to be 79 hours a week, of course. And if I do 79 divided by 80 times 100, it's almost 99% uptime. Is that good? %99 seems pretty good, doesn't it? But consider 200 employees, and if their work depends upon the server being up, that's 1 hour a week they're losing, right? Times, let's say they make $25. Now this is per week, so that's for the week. Take that and multiply that times, how many weeks are there? 52? So by having that 1 hour a week, you're down approximately 99% uptime, you're losing $260,000. That's significant, isn't it? They push this quite a bit, that your server, your systems has to be up like 99.99% of the time. That's what they want. Can't have this, because that is a huge chunk of money to lose. Well, are they going to have the same sense of urgency at a cloud service that you would in your company? So again, penalties. System performance. Well, if it's twice as slow as what you can offer, then you're going to lose a lot of money. Fees, and then provide software hardware, of course. CSAs define the scope of services the CSP provides. We've got service hours, restrictions applied to customer by the CSP, availability of the cloud to the customer, levels of support, response time for data transfers, throughput, limitations, contingency plan for incident response, and business continuity and disaster recovery plan. What happens if the server crashes? How long are you going to take to get that up? I remember at IFR one day, and I mentioned this, I'm sure, but the power pole got hit. Transformer went down. We lost power to the plant. They sent us all home. I was happy. I was salary, so I didn't lose any money. They had hourly employees there though. They had 400 hourly employees. I think they lost probably about 7 hours worth of work, and let's say they're making approximately $15. So this is the lost amount. By the way, up here, if I company hires me for $50,000, how much value do you think I add to the company, monetary wise? If every employee, think of this just overall, if every employee was paid 50,000 and your only value you gave back to the company is 50,000, what would happen to that company? Yeah, they'd go under, wouldn't it? Nobody. That's zero gain. So probably when you work for a company, they pay you 50,000, they're getting $100,000 worth of value out of you, out of projects, out of profit, out of whatever you're giving them. So even over here, this 260,000 per year, you could probably take that and you actually multiply it times 2, and that's $500,000 lost each year. So down here, they lost 84,000 because there was no contingency plan for the electrical. Now they talked with the company after that to see, well, what happens if we lose our power again? Can we have is there a way we can have it set up such that the power comes from a different direction? Sounds weird, but you got more than just this item here. You got customers that have their orders delayed. How about here? If tornado hits this building, wipes it out. Does Cali have a plan? How they do their classes? Probably not, right? They should. Computer-wise, I could, do it from home. That's not a big deal, but they got a lot of equipment out here, don't they? So what would they do? Say, hey, we're done. Call it good for the semester. So, you got to have some kind of plan when things go wrong. Now, that isn't just a good idea. Accreditation, they look at things like that. Do you have a plan if something happens? Coke Industries, they took out life insurance on all their employees, professional employees, salaried. Most places don't take it at the level like a computer programmer, but they want to take life insurance out on me. So if a tornado went through and killed every employee in Coke Industries in a building, they could continue. They get this life insurance money that help offset it. CSAs define the scope of the services CSP provides, fees for the subscription to the cloud, and fees for additional services as they occur. Security measures, terminology, the cloud system, and applications. People are so used to saying it's in the cloud, they don't really understand even what that means. CSP components must state who is authorized to access data and what limitations are and conduct acquisitions for an investigation. Policy standards and guidelines for CSPs. Digital forensics should review CSP policies, standards, and guidelines for daily operations. Policies are detailed rules for a CSP's internal operation. Standards give guidance to staff for unique operations, hardware, and software, and describe the staff's obligations regarding security of the CSP environment. And that may come from an external organization. Oftentimes standards do. or could be standards and guidelines may come from government organizations. They're not necessarily dictating, but they're outlining. Guidelines describe best practices for cloud processes and give staff an example of what they should strive to achieve in their work. I've mentioned that ISO certification. I'm sure there's ISO certifications on cloud standards. CSP processes and procedures are detailed documents that define workflow and step-by-step instructions for CSP staff. Often include hardware configuration diagrams, network maps, and application processing flowcharts. Digital forensics examiners can use them to understand how data is stored, manipulated, secured, backed up, restored, and accessed by CSP staff and customers. And then there's additional documents of interest, including the business continuity and disaster recovery plans. You'd be surprised what they put into those business continuity and disaster recovery plans. Goes down to where are you going to store your backup tapes at if you're backing something up. Now, jurisdiction issues. Though there are plans to revise current laws, many cross-jurisdictional legal issues haven't been resolved. It's kind of brand new. No law ensures uniform access or required handling procedures for the cloud. Investigators should be concerned about cases involving data commingled with other customers' data. Got to figure out how to isolate just that individuals. And sometimes that's hard because it may not be on a personal account. They may be storing it just under a directory, under the company's data. For example, if I was a webmaster and I had inappropriate pictures, well, I could create a folder for that under my company's web server. And because really, any kind of warrant and so forth will probably be geared toward my own personal data, not the company's resources. So again, it gets confusing when you have all the different options. Often figuring out what law controls data stored in the cloud is a challenge. A lot of lawyers and legal professionals haven't dealt with it, so they don't know what the laws are. How privacy rights are defined in different jurisdictions is a major factor in problems with rights to access data. The EU directive 9546 EC is more restrictive than rules in other countries, including the US. Protects private information for all EU citizens. I would expect it to be less restrictive. But digital forensics examiners could be held liable when conducting an investigation involving cloud data. They need to consult with legal experts to be aware of the possible restrictions. Why do you think the EU is more restrictive? Fairly brand new, right?
Yep.
So, they actually sat down and talked about what it should be. A lot of things that are happening now are reactive. Based upon something that happens, then they'll pass a law or come up with some kind of rules and guidelines. The ECPA, Electronic Communications Privacy Act, describes 5 mechanisms the government can use to get electronic information from a provider. Search warrants, subpoenas with prior notice to the subscriber or the customer, court orders with prior notice to the subscriber or customer. Would any of these work if your cloud provider was over in Russia? No, they wouldn't honor any of that, right? There's a huge problem with some of these. By the way, if I was going to do something illegal, would I go with one of the standard cloud providers in the United States? No, why would you? That'd be the stupidest thing in the world. You go find one from another country. Search warrants can be used only in criminal cases, must be requested by a law enforcement officer who has evidence of probable cause that a crime was committed. Law requires search warrants to contain specific descriptions of what's to be seized. For cloud environments, the property to be seized usually describes data rather than physical hardware, unless the CSP is a suspect. Must also describe a location item to be seized. Again, difficult when dealing with cloud data because servers are often dispersed across state or national borders. Must establish how it will be carried out, specifying date and time of day to minimize disruptions to people and business operations. Now, subpoenas and court orders. Government agency subpoenas, customer communications, and records can't be knowingly divulged to any person or entity. Used to get information when it's believed there's a danger of death or serious physical injury. Non-government and civil litigation subpoenas used to produce information from private parties for litigation. And court orders written by judges to compel someone to do or not do something. Now, these are technical challenges in the cloud forensics. Challenges in conducting cloud forensics. There's the architecture, data collection. What do I mean by architecture? I think that all the standard ones that would be handled by the existing software. Data collection. That's just a challenge because of the lot of different items like the location of the data, as we mentioned. Analysis of the cloud forensics data. Pretty much if you can bring it down into some kind of format, that a lot of that isn't the same as, although a lot of it's the same, so it's not a huge deal there. Anti-forensics, incident first responders, role management, legal issues, standards, and training. No two CSPs are configured exactly the same way. I think I was reading about that the other day about how the technology keeps changing. The server software keeps evolving to where it's not just making slight changes. So how often do they come up with a new Microsoft server? Not very often, do they? It's not like they come up with it every year. So when they do come up with it, then there's usually a fairly big change there. Data can be intermingled. Most CSPs keep data storage locations secret for security reasons. Instead of hacking into somebody's servers to grab their information, if they're storing it out in the cloud, you can hack into the cloud provider, right? But we already looked. There's so many Amazon servers providing that feature. Well, you have to spend a lifetime trying to search through to find one company. So again, they try to keep a lot of that secret. Differences in recording procedures of log keeping can make it difficult to determine data's origin, and complicated investigations chain of evidence. If I looked at files over here, I got this runme.bat under users Kali instructor. Got it right here. I can right click on this, choose properties. As I look through this, date modified is 3/6. Does it tell me who modified it? No. Sometimes, depending upon your infrastructure, your networking will keep track of who made changes. So you can see who last made changes to the file. So depending upon that, then there's different ways of verifying who's made changes, who's deleted a file, who's changed it, and so forth. So if our webmaster did put something inappropriate up on I'm not saying he is, but if he did put up something inappropriate on a folder, you could potentially see that he's the one actually accessing it. Otherwise, if you got 4 people accessing it, can you say whose files they are? No. So again, may have other data available or log records. Data may need to be reconstructed to determine what actually occurred during an incident. Some of the items that may occur in a crime, they delete their evidence, any kind of trace of what was done after they finished. Examining logs can be useful to compare the modified, last access, and create MAC dates and times for files. Now, our anti-forensics destroy an ESI that may be potential evidence. Hackers may use specialized malware for defeating evidence collection. And additional methods for anti-forensics, inserting malware programs in other files, using encryption to obfuscate malware programs activated through malware programs, and using data hiding utilities that pin malware to existing files. Other techniques affect file metadata by changing the modify and last access times, and changing timestamps can make it difficult to develop a timeline of a hacker's activities. Calculating hash values of files and comparing the results with known good files hash values can help identify files that have been altered. So again, they're like putting some kind of executable out there. They'll do some damage if you try to perform the anti-forensics. Maybe they might try to prevent you from doing it, or it might actually just destroy the evidence. There's incident first responders. CSPs have personnel trained to respond to network incidents. They become first responders when a network intrusion occurs. When CSPs do not have an internal first responder team, the forensics examiner should organize CSP staff to handle these tasks. Some factors to address include: will a CSP's operations staff be cooperative and follow directions, and will management issue orders stating that you're the leader of the investigations? Do you need to brief staff about operations security? For example, you might need to explain that they should talk only to others who have a need to know when incident and investigations activities. Do you need trained staff in evidence collection procedures, including chain of custody? Sometimes just by talking too much about what's going on, you create other legal issues or create other issues in general. I think I told you about the guy from Coke got fired. posting stuff about the network in some kind of forum. Yeah, he can't do that. Because by just generally talking about something, you let people know your own vulnerabilities and how people can hack in. Should anybody in IT ever talk about how they have set up their network? No, why would you? Um, if you're working with a sister company, maybe to get them, set up the same kind of configuration. But now, role management in the cloud covers data owners, identity protection, users, and access controls. And as an investigator, you need to collect this information so you can identify additional victims or suspects. Now, for our standards and trainings, effort to standardize cloud architectures for operating procedures, interoperability, testing, validation. And there's the Cloud Security Alliance, CSA, has developed resource documentations for CSPs and their staff. And cloud investigators should have an understanding of cloud architecture in addition to basic digital and network forensics skills. And sources for cloud forensics trainings, ISC2s, or squared, Certified Cyber Forensics Professional, InfoSec Institute, SANS, Cloud Forensics with F-Response, National Institute of Justice Digital Forensics Training, and University College Dublin Center for Cybersecurity and Cybercrime Investigation. Why do they worry about all this? Come up with standards. Why do I care what everybody else is doing? I set up what?
For data, because you could be using them, because you notice you're using theirs. Let's say you log into a website and you buy something there. You could be on their, like they can have their servers on that, their servers on the cloud or a different company, and you want to streamline.
Yeah. Maybe interoperability. Maybe like I say, you're working with a company, and if you're gonna have business dealings with them, you want to make sure they fall into certain standards. Sometimes it's there just to ensure the government doesn't crack down on you. Like if they got a major intrusion into Amazon servers, and they lose millions of pieces of information to hackers. What's the government likely to do? Pass their own rules, right? Saying you will do this to ensure things are seen. And people don't like that. You don't want the government dictating it to you. You'd rather on your own kind of decide how should you do it. It's kind of true in a lot of organizations here at Cali. We redid our developmental math. And there was a reason for it, because the state was getting ready to dictate it across every college, telling us what to do. And so we wanted to get everything in place, so we go to the state and say, hey, we've already got a plan for how to handle our issues in developmental math. So again, you'd rather be proactive and come up with your own than have it dictated. Now, acquisitions in the cloud, methods used to collect evidence in cloud investigations depend on the nature of the case. Recovering deleted data from cloud storage might be limited to the type of file system the CSP uses. Some are better than others in that regard. With cloud systems running in a virtual environment, snapshots can give you valuable information before, during, and after an incident. Forensics examiners should recreate separate cloud servers from each snapshot, acquire an image of each server, and calculate a hash for all files. Snapshot before might be like a backup. So you're looking at a backup, and and doing hashes on all the files, and then you can see what's happened. During is sometimes a challenge. After is easy. Now, encryption in the cloud. Many CSPs and third parties offer encryption services for cloud users as a security measure. Expect to find encrypted files in cloud investigations. If I'm going to store all my personal information up there in the cloud versus my flash drive, I expect it not to be stolen. So they expect a higher level up there than you would like just on a device you plug into your computer. You need assistance from the data owner or the CSP to decrypt data with the right encryption key, assuming there's that type of encryption. If data owner is uncooperative, you may need to turn to the attorneys handling the case or data owner's management. Encrypted data in the cloud is in two states: data at rest, data has been written to a disk, and data in motion, data being transmitted over a network. And some systems also have encryption for data in use, data that's in RAM. If encrypted data is encountered, find out from the CSP what type of encryption is used and who knows how to recover it. And vendors that offer encryption services for cloud data, Attila Cloud Encryption from Micro Focus, Secure Cloud from Trend Micro, and Safeguard Encryption and Sophos Mobile Control from Sophos. Homomorphic encryption uses an ideal lattice mathematical formula to encrypt data. Then there's blockchain technology used by companies such as Bitcoin, is a way to trace your information while keeping it secure. Now, when conducting a cloud investigation, use a systematic approach just like the ones covered in the first chapter. Type of incident determines how to proceed with planning an investigation. Obviously, a terrorist attack and trying to find information on the cloud is a lot different than somebody with some bad pictures up there. You're going to have a lot more resources, a lot more subpoenas and so forth from a government agency in one example. If the investigation involves searching for and recovering data from cloud storage or cloud customers, follow methods described in chapters 5 and 6. Investigating CSPs. If a CSP has no team or limited staff, investigators should ask the following questions to understand how the CSP is set up. Does the investigator have authority to use cloud staff and resources to conduct an investigation? Is detailed knowledge of the cloud's topology, policies, data storage methods, and devices available? And are there restrictions on collecting digital evidence from remote cloud storage? For e-discovery demands on multi-tenant cloud systems, is the data to collect commingled with other clouds customers' unrelated data? Is there a way to separate the data to prevent violating privacy rights or confidentiality agreements? Is the data of interest to the investigation local or remote? If it's in a remote location, can the CSP provide a forensically sound connection to it? It's not like you can go grab the server and remove it, is what you're saying. You have to find some kind of technique to get data. If a cloud customer doesn't have the CSP's application installed, you might find cloud-related evidence in a web browser's cache file. If the CSP's application is installed, you can find evidence of the file transfers in the applications folder, usually found under the user's account folder. Have you ever used one of those CSP applications? It is just like you have some cases just have their own folder. And under that folder is where file transfers are stored. That's the way that Mac in the cloud was. I think I have had it on my flash drive. Not that I probably can recognize the name, but I don't know if it's Mac in the cloud. Mac in the cloud. I don't think this one. I don't think this one stored anything in these files though. I don't think I ever tried to transfer any files down. Maybe it would have been stored in that folder. Prefetch files contain the DLL path names and metadata used by an application. And the OS reads the associated prefetch files and loads this information in the computer's memory and speeds an application start time. OS can handle other tasks instead of waiting for an application to load needed libraries. Example, metadata in a prefetch file contains an application's MAC times in UTC format and a counter how many times the app is run. And this is showing in this this file here. Looks like Dropbox. Last access date and time. Number of times applications run. Record date and time. Modified date and time. Create date and time. But again, you got to be able to translate this. Now, examining stored data on a PC, the three widely used cloud services: Dropbox, Google Drive, OneDrive. I haven't done very much with OneDrive. I use Google Drive, and I've used Dropbox. Services are free for storage up to 2 GB for Dropbox and up to 15 GB for storage for Google Drive and OneDrive. These applications have registry entries, and users must maintain control over access to their cloud accounts. Dropbox offers third-party applications such as email, chat, Cisco WebEx, and other collaboration tools. Since 2012, Dropbox has used base64 format to store content. Reading them requires specialized software, and Magnet Forensics has a tool called Internet Evidence Finder, IEF, designated for this purpose. Now, part of that is they try to be more secure. If you have to have a special tool, then that adds another layer of security. Gmail users have access to Google Drive for cloud data storage and applications. Actually, when you're using your apps and so forth, whether it's Gmail or Sheets or whatever, it actually stores it out there. So it's consuming memory. I upgraded my Google Drive just because I was sending emails with huge attachments that sound like PDFs and so forth, and documents and zip up files and send them and so forth. And I was running out of disk space. I paid $1.25, I think, a month. It's a ridiculous small amount. Google Drive is installed in C program files x86 Google Drive. This is assuming you have some kind of connection. You don't have to install it. Each user has configuration files stored in the user's username, app data, local Google Drive, also called user profile. And if Google Drive has been installed, it creates a folder in the path, user's username, and then Google Drive. Important Google Drive files: sync_config.db, an SQL database file with Google Drive upgrade number, highest application version number, and local synchronization root path. Snapshot.db contains information about each file access, or the URL path name, modified and created dates and times in Unix timestamp format in the files, MD5 value and size. And sync_log.log has detailed list of users' cloud transactions. That's probably an important one there after you find your files. Got OneDrive. This is Microsoft's. Originally called SkyDrive. I don't remember it being called SkyDrive. Came out Windows 8. Similar to Dropbox and Google Drive, and offers subscription services for Microsoft software. There's that free version of Microsoft Office, like I said out there, but then you can add on to it and pay per month. OneDrive stores users' profiles and users' account path, and log files and synchronized files are kept in various places under the user's account, depending upon the Windows version. And you can find more information following Windows 8.1 log files, which are in the C users, username, app data, local, Microsoft, Windows, SkyDrive, logs folder. And I go for that. Now, Windows Prefetch artifacts. You can collect Prefetch file artifacts with the disk editor or forensics tool, and follow steps and activity on page 546 to use WinHex's data interpreter to find application MAC dates and times, and number of times Dropbox is run. And we're not going to look at that, but that's a picture they had up above showing where those are stored at, and the offset. Few tools designed for cloud forensics are available. Many digital, network, and e-discovery tools can be combined to collect and analyze cloud data. And some vendor with integrated tools, guidance software in case, access data, and F response. You got forensics OpenStack tools, Frost. Integrates with OpenStack running in IaaS cloud environments. This adds forensics response capabilities for a CSP. You got OpenStack, an open source computing platform intended for public and private cloud services. And Frost is the first known effort to provide a forensics response process for a cloud service. The feature of Frost bypasses a VM's hypervisor. Collected data is placed in the cloud's management plane, which is a tool with application programming interfaces, API, that allows reconfiguring the cloud on the fly. And special malware can take control of the virtual session and deny or alter access. And it can also prevent or interfere with forensics analysis and data collection. F-Response is a remote access tool. Two tools are needed, F-Response Enterprise or Consultant, Kernel Pro, USB over the Ethernet. Then there's Magnet AXIOM Cloud. Magnet AXIOM created a cloud module to go with its process and examine modules. Magnet AXIOM Cloud retrieves information from Facebook Messenger, Skype, Instagram, Twitter, iCloud, and others. But you still need usernames and passwords. And then just a summary of what we just covered, so I won't go over that. And that's chapter 13. Not too exciting. Hopefully the labs are a little bit more exciting than that. I'll go ahead and stop recording there.